eye, the most important and precise optical instrument given by the nature to the human being. Eye mainly consists of lens and retina behind it. Retina is behind the lens, and when the object is placed in front of the cornea, means the cornea will give the security for the lenses and from the air particles like that. Then whenever the object is placed in front of the lens, and due to the retina consists of some cells, cones, and at the same time due to that one the messages can sent through the optic nerve to the brain. Means when the object or whenever we see the picture, then the image is formed. Retina behaves like a screen for the image. Means image is formed, inverted image is formed on the retina, and that image, because of retina consists of cones and cells and rods. So from that through the optical center along the optical nerve, that message is sent through brain, and automatically brain will read the messages and gives the picture to see the image, and also the image is formed on the retina will be the inverted image, and it interprets into the erect image. Brain interprets into the image. Then the normal eye can see the object situated between the distance of infinity to the 25 centimeters. Normal eye can see, normal eye can see the object situated between infinity to 25 centimeters, in front of the retina. Then whenever the object, we can see this is possible by changing the focal length of the lens, means by changing its focal length of the lens by the ciliary muscle. Because of between the ciliary muscle the lens is situated. By changing this muscle, then we can change the focal length of the lens. So here is that it is possible, means the visible can be possible between the whenever the object is situated at the infinity to 25 centimeters, because of by changing the focal length of the eye, that is called so that's why here when eye is relaxed, the infinity objects can see easily, but when the object is taken to the nearer to the eye than the infinity, then the ciliary muscles will tenses. This will be tenses, almost all it will be tenses, and this lenses almost becomes spherical, and its focal length will be reduced. So that the image can be formed in the retina. So that's why you can say that by changing the focal length of lenses, then we can be visible between the infinity to 25 centimeters. Then the ability of eye to change the focal length of the lens is called power of accommodation. The ability of eye to change focal length of lens is called power of accommodation. Means when the ciliary muscles will tenses, then it will be tenses, and it will almost spherical, means the lenses becomes almost spherical. So that's why that is changing the focal length is called as a power of accommodation. Whenever the near point and power point, means whenever the object is placed, the extremes of ranges over the objects is situated is called as a far point and a near point of the eye. So means whenever the far point and a near point, far and a near point. Far and a near point means when the object is placed that eye can see clearly, that maximum distance is called as a far distance. Means the maximum distance that can eye is clearly visible. Clearly visible distance means the maximum distance that I can clearly visible distance is called as a far point. This is called a far point. The minimum distance, approximately the minimum distance will be 25 centimeters in front of the eye, that can be seen in normal human eye can see 25 meters distance, that is the near point of our eye. So here it is that the near distance that eye can clearly seen is a near point. For the normal eye, 25 centimeters is the near point. 25 centimeters is the near point. By changing this focal at the far points and near points, by the age also there is a change will be there in the nearer points. They are that at the age of 10, then this is the age and this is the centimeters, distance in centimeters. That is at the age of 10, 7 centimeters will be the nearer point, and at the age of 20 then 10 centimeters, and at age of 30 the 14 centimeters, and at the same time wherever age of 40 then that will be the 22, and at age of 50 the distance will be 40 centimeters, and at age of 60 200 centimeters be the nearer point for the distance, near point for the human eye. So this is happens due to the in some cases also approximately some of the defects also there, by damaging the lenses or retina, some of the defects will be happen. Now let's discuss about the defects of eye. One of the defect of vision is myopia. Myopia means it's called nearsightedness or short-sightedness. Means the human eye which is having the defect of myopia can see the nearer objects only clearly. Means when we see some of the candidates we are reading the newspaper by putting the newspaper into near to the eye, like that. Means that myopia means it's a short sightedness, that defected eye can see the nearer objects clearly, cannot see the far objects clearly. So means whenever the light ray, means the rays of object which is in front of this, rays of objects will be formed. If in case of this some of the object is placed in this place, then rays are formed in front of the retina. Means by, if in case of the rays is formed in front of the retina, that cannot reach to the directly reach to the retina. So that's why they in front of retina. To reduce this problem, we will use the diverging lens. By using the diverging lens, then that defect can be make up. Means that defect can be reduced whenever the light ray is incident on that. Due to the divergence of this, then it can clearly incident on the retina, that the image can be visible. Here that whenever the light ray is incident on this due to the divergence of lens, then incident on that and incident on the retina. Means the object far point will be the infinity. Like this. Means the image is formed, means like this. If the image is formed in front of the retina, the human being can't see, that is called as a myopia or nearsightedness. And let's see the myopia means consider it's a human eye. This is the lens. When the light ray is incident on the lens, then that image is formed in front of the retina. Consider this is the retina. This is the retina, and object light is placed in this. Whenever it is reached to this, then it will be the retina. The image is formed in front of the retina. Means the far point will be infinity. Far point will be infinity. To defect this, to reduce the defect of this myopia, we use a diverging lens. Diverging lens means concave lens. This is the lens, and this is the retina, and by using the concave or diverging lens, whenever the light ray is incident on the diverging lens, and it can be incident on this, and correctly by equal focal length, by measuring the defect, when we can see the focal length of the image, then we can see the image is exactly formed on the retina, then the myopia problem can be defect reduced, because of by using this the distance we can measure, means this is the principal axis, then the distance will be object is x from the distance of the lens, means here it is the distance of x. From this we can write that 1 by v minus 1 by u is equal to 1 by f is the formula, lens formula. We have that. From that we know that the image is formed at the x distance. This is the opposite direction of the incident ray, so that's why we are writing that v is equal to minus x and u is equal to, we know that the far point will be infinity, then object is placed at the infinity, then we can get that 1 by minus x minus 1 by infinity is equal to 1 by f. From the distance we can write that f is equal to minus x, means here by using the distant object we can measure that. By using the concave lenses we can reduce the myopia or short sightedness. Once again, myopia means it's a short sightedness or near sightedness. This defect of eye can see the nearer object clearly, cannot see the distant objects clearly. So that to reduce this problem, for the remedy, we will use the diverging lens called concave lens. Diverging lens or concave lens we will use so the far point of the myopic eye will be infinity, so that 1 by v minus 1 by u is equal to 1 by f. From that formula we can get that the focal length of that eye is f is equal to minus x. So another defect of vision of eye is hypermetropia. Hypermetropia means a person suffering with the defect cannot see the nearer objects, means can see only the far objects only clearly, cannot see nearer objects only, means when the light ray is passing from that, then here that when the light ray is incident on this, then the image is formed behind the retina, so that he cannot see the nearer objects, only he can see the far objects. And whenever the object is moved to the far distance, he can see clearly. Means like this, to reduce this problem, means the image is formed behind the retina. To reduce this, to make up this defect, we will use a converging lens or convex lens. This is a convex lens or it is called also converging lens. By using converging lens, when the object is placed, when the incident, it actually by changing its focal length, by using the suitable focal length of converging lens, then the image can be formed on the retina clearly. So then the actual image, near point of the image will becomes distance is y. Actual distance of the image will be 25 centimeters, near point of the image, but by the which is having the person having the hypermetropia, the distance object will be, the near point will be changes. So to find out the focal length of that eye, then we have that the near point will be 25 centimeters, then the far point remains infinity. So that is 1 by v minus 1 by u is equal to 1 by f. Then 1 by minus y, we are taking that the image is formed at a y distance, so that's why 1 by minus y, and minus of 1 by minus 25. From that f is equal to, by the calculation, 25 y by y minus 25 be the equation to find out the focal length. Then how much the focal length of convex lens we required. Then only by finding that one we can find the suitable focal length of convex lens to defect, to reduce the defect of hypermetropia. Once again, hypermetropia means it's a farsightedness, means a person is suffering with this defect, can see the far objects clearly but cannot see the nearer objects clearly. So it is the image is formed when the object is seen, the image is formed behind the retina, so that's why he cannot see the nearer objects. So that's why by using the suitable focal length of convex or converging lens we can rectify, we can make up this defect by using this near point will be 25 centimeters and far point remains such as infinity. So that's why the sum of the distance that image can be formed. By using the convex lens we can rectify the hypermetropia. And also another problem of eye is another one is presbyopia. Presbyopia means it's a aged sightedness, means by increasing the age the muscles strength will be reduced, so that's why the human being can't see the nearer objects and far objects clearly. And so that to reduce this problem we should use two spectacles, otherwise we should use bispectacles, means bi-lens spectacles we should use, means the upper layer of the spectacles must be used concave and lower with the convex to reduce this defect. Presbyopia is old sightedness, means by increasing the age the muscles of eye will be, strength of the muscles of the eye will be reduced, so that the eye cannot see the objects clearly, the nearer objects and the far objects also we cannot see clearly. So to reduce this presbyopia we should use two type of spectacles, or by using the bi-lens spectacles also we can rectify the problem. By use the at the top of the layer of the lenses will be concave and bottom of the layer can be convex. By using that lens we can reduce the defect of presbyopia. Presbyopia means old sightedness. And another problem is there, presbyopia, and another one is astigmatism. Astigmatism, this is the another type of defect of an eye. By using the cylindrical spectacles, by using the cylindrical lens, this kind of when the eye lies has different curvature, eye lens has a different curvature along different planes, means in this eye different curvatures of lens is there, so that's why that they are having the different curvatures of lens in the different planes, so that's why that eye can't be seen every object clearly. So that's why to reduce this astigmatism we will use a bi-lens, and to reduce the astigmatism problem we use cylindrical spectacles, cylindrical lens or cylindrical spectrum. Say presbyopia means old sightedness means by increasing the age sightedness, and astigmatism, this is kind of a signal that it is having the eye having the different lens in a different planes in eye, planes of eye. That eye, this kind of astigmatism having the different lens of eye in different planes. So that's why due to astigmatism, by using the cylindrical lenses we can reduce the astigmatism defect. And by the presbyopia means it's a old sightedness, by using the bi-lens means convex and concave, means myopia and hypermetropia. The body cannot see, the eye cannot see the nearer objects and far objects clearly. This is about defects of vision, means myopia, that's a short sightedness. The eye, defected eye can see nearer objects only, can't see the far objects. That is concave lens, diverging lens. By using the diverging lens we can reduce the myopia. And hypermetropia means it's a hypermetropia is a farsightedness by using the convex lens, means converging lens. Convex lens means converging lens. By using the converging lens we can reduce the hypermetropia. It's a farsightedness. The image is formed behind the retina. So by using the suitable focal length of convex lens we can reduce the hypermetropia. In that hypermetropia, objects can be seen, far objects can be seen clearly, not nearer objects. And another defect is presbyopia. It's a old sightedness. By using the bilens or myopia, hypermetropia, both conditions will be faced by the presbyopia. So in presbyopia, old sightedness, by using the bilens, concave and convex lens, we can rectify it. And astigmatism, this is a different type of defect of vision. This is having the different lens in different planes. So by using the cylindrical lens we can rectify this, we can make up this defect. This is about defects of vision and about the human eye.